Just going to say that this Hangout on there is live. And this is me preparing for a talk that I was asked or requested to give to the South Florida Test Automation Meetup. And I recorded a video a quarter after 6. I think it was a quarter after 6. Maybe it was a quarter to 7 earlier this morning. And that was volume 1. This was volume 2 of me practicing preparing to hopefully go on autopilot and give my dissertation at this South Florida Test Automation Meetup. Yeah, okay. So I had kind of verbally put together an outline of what I wanted to talk, and I gotta like somehow connect the dots. So like if I share my screen, come here, Willis. Yes, I share my screen. So something that I definitely want to talk about is I need to talk about object. I need to say, what is object-oriented programming, okay? And then I have to say, well, that probably should have a question mark. And then I should probably say something. Oh, shoot, what just happened? Then I should probably say something like, okay, well, what is functional programming? Something like that, right? And something like that, right? It's probably how I want to start off this discourse, okay? And so then I probably would ask, okay, we should shorten this up, reduce 3 by 2. And so I should probably say what's apostrophe S, and I'll probably say what's apostrophe S, and I should say what's the difference or difference between, I guess that has 2 F's in it, right? Come here. Between OOP and FP. Yes. Come here. Yes. Come here. Yes. Okay. And so I'll probably ask the audience that. And then from there, what did I accomplish? What's the reason why I would ask these questions in my talk? Well, I would ask these questions in my talk to set the tone or to set a context of why property-based testing is useful and what ecosystem it belongs to. And when I say ecosystem, at a very high level, it's object-oriented programming or functional programming. And then if you go a lower level of abstraction, it will be, your C#, your Java, your Ruby, any other object-oriented programming languages in which they have their own ecosystems, such as frameworks, libraries, maybe some other technologies that more than likely are going to fall into frameworks, libraries, okay? Okay. So again, to summarize, I asked, what's object-oriented? Oh, shoot. Oh, yeah. I asked, what's object-oriented programming? And then I asked, what's functional programming? And then I asked, what's the difference between the two then? And when I ask these, then I probably go to Wikipedia for the definition. And then I need to basically tie these things together so that I can deliver the topic of property-based testing. In order to do that, I could say that, I could say, come here. I need to stop saying, I found myself saying that a lot when I review my video from this morning. I'll try to not use the phrase, you know. Okay. Now, what I want to do is I then want to ask some questions about what's an ecosystem, something like that. Come here. And someone will raise their hand. It'll be interesting. And then I'll go to Wikipedia definition of ecosystem. Okay. Or just a general dictionary term for ecosystem. Ultimately, ecosystem, if I hurry up and look it up, is going to be ecosystem. Come here. And of course, I can't type into that. So I will type into this over here. And I could say ecosystem. And it says a biological community of interacting organisms and their physical environment. I'll cross out biological and I'll just say a community of interacting organisms and their physical environment. I need to cross out organisms as well. Potentially say a community of interacting technologies in their physical environment. That's probably what I would take from that. And I would basically, well, state that in front of the audience. But then why am I talking about an ecosystem? Well, I have to then say, well, you have object-oriented programming ecosystem, and then you also have your functional programming. Oh, this is not working. And you also have your functional programming ecosystem. Okay. And so in this case, it's functional programming because the context is going to be on F#, it's going to be a functional first programming ecosystem. And so here we can say like WPF, or maybe type it out, Windows Presentation Foundation. Or maybe we don't have to be specific. Maybe we could just say UI frameworks, test, unit test frameworks. And do that. And we can say libraries, or specifically NuGet packages. Say something like that. And the thing is we have the same thing over here. Okay. But, okay, and I probably want to say unit test frameworks at the end. So that I can maintain focus on the last thing that was mentioned. If I do that at the end, then maybe I should move NuGet packages to the beginning. Really call it libraries. And then I could say IE NuGet. Something like that. And same thing over here. Okay. So within the unit test frameworks, I could provide an example of, I just said again, even when I tried to make an effort not to say that. For unit test frameworks, I could provide an example of in unit, X unit, MS test. And there's others, I think like Expecto, which I don't know anything about. But so these are some unit test frameworks. And over here, for functional programming, I'm basically going to say the same thing. But then this in the talk, I'm going to say, oh, by the way, there's one difference between the test automation frameworks used in object-oriented programming versus the test automation frameworks used in functional programming. And I'll say specifically, based on the paradigm or based on how we program in functional programming, the idiomatic way of writing code via functional programming, this isn't really possible in object-oriented programming unless you write functional code, unless you write code of that's pretty much functions everywhere. That's ubiquitous when it comes to functions. And so maybe I'll phrase it like that, but a little cleaner, and I'll say FS check. Okay. So what separates FS check from in unit, X unit, MS test is FS check is a framework that will basically generate the edge cases for you. Now, I want to take that back because I'm not ready to introduce FS check yet. Instead, I'm going to have a separate bullet point saying, what's a unit test? Okay. I want to put that in there. And my dog is making demonic noises. So I say, what's a unit test? And people raise their hand and say what a unit test is. And then I would basically say a unit or I'll say, what are examples? I don't have to type all that in. I'll just say capital E for examples. Okay. And do that like that. And so then I draw the conclusion that a unit test is essentially a property-based test. Okay. So I could say unit test equals property-based test. All right. And I would really say no, I'll change that back. Not property-based test. A unit test is an example-based test. like that. Okay, so that's what a unit test says. Let me repeat that. I'll ask what a unit test is, then I'll discuss examples, and then I say, well, based on these examples, when you specify a specific input or inputs, plural, and then you specify a specific output, then what you're really specifying are examples. So a unit test is really an example that you're using. It's a specific case, okay? Your unit tests are cases. They're examples. So once I establish that unit tests are really example-based tests with specific examples, hence hard-coded values, then I could say, well, I could then say, well, what's an edge case? Which is probably going to be separate over here. And I say, what's an edge case? And then I would probably ask, first I would go to like Wikipedia's answer of what an edge case is. And then I would say, how do we identify, good word, edge cases? I would do that. And people will say, well, you have to perform critical thinking. And, that's why you hire testers, because they'll think of clever ways of breaking software. Okay. So then I say, are edge cases, I'll say, how can we rely on computing to generate edge case scenarios or edge cases for us? How can we rely on computing for edge case generation? Or you could say for generating edge cases, or for generating edge case inputs. I'm not sure how I want to phrase this, but how can we rely on computing? Or let's make it more simple. Is there a way to auto generate edge cases for us? Simple like that. Pass that to the audience. They already know what the answer is going to be if they reviewed the I don't know, not program, but if they review the summary of what this talk is going to be about, then they're going to say property-based tests, right? But I can almost guarantee that none of them have experience with it. So, all right, so this is a general outline. What's object-oriented programming? What's oh shoot, what's functional programming? After that, and then I say, what's the difference between object-oriented programming and functional programming? And then I ask, what's an ecosystem? And somehow I say, well, there's ecosystems for computer programming, right? When we think about .NET, when we think about Ruby, when we think about Java, they have their own ecosystem, do they not? They have libraries with their own individual package managers. All right, so maybe I should say package manager. Yeah, maybe that's better. So they have libraries with their own package manager implementations. They have UI frameworks, and also they have unit test frameworks. Something like that. And then I ask what a unit test is. They give me a definition of a unit test. I ask them for examples. They provide examples. And I say, well, it sounds like based on the definition of, well, it sounds like based on the examples that you provided of a unit test, these are specific cases. These are specific examples. You specify inputs, you specify the output. So this can really be called example-based testing. Okay. And then after I say that, I then ask, well, what's an edge case? And then they say what an edge case is. I'll take them to the definition via Wikipedia. And then I ask, how do we identify edge cases? And then they'll go into the way that they identify edge cases, which is basically relying on human intelligence. And that's fine. And then I pretty much say, well, what if I told you that instead of you as a human being or as a talented tester creating these awesome scenarios that people really didn't consider and taking your time to really brainstorm what these scenarios would be and how the system should behave as a result of these specific scenarios for both happy path and sad path. What if I told you that we can auto-generate edge cases? Or we can really, not edge cases, but we can auto-generate the inputs, the data inputs that will flush out edge cases that we need to make accommodations to the code, or that I can say that we can that would potentially result in alterations to the system under test. So let me start over. I could say, what if I told you that there is a way to auto-generate data inputs that will flesh out edge cases for you so that you don't have to brainstorm them yourselves? Would you believe me? If I told you that you can write code and it will do, or it will identify the edge cases for you, how would that make you feel? Right? Something to that degree. And then I would basically say, introducing property-based testing. And I'll give a high-level summary of what property-based testing is, which I define it as, I define it as a technique used to challenge your assumptions. Okay? That's how I would frame it about a function. Yes, like that. Okay? So introducing property-based testing, and then I would say a technique used to challenge your assumptions about a function. I'll just leave it short like that. And then from there, I would say demo time and adding, I would say addition and multiplication. Can't spell. Something like that. Actually, I should do something like this. I'll say demo. Oh, come here. Demo. Oh, demo. You don't have to. And then the demo will be for addition, it's the sum of two numbers. I keep on saying the product of two numbers. I think product is multiplication or something. The sum of two numbers will or is greater than each individual number. The sum of two numbers is greater than each individual number being added. And then the other one would be an assumption that the product of two numbers is use the same thing right here. Is greater than each individual number being added. So I'll do something like that. And to conserve space, something like that. Product of two numbers is greater than each individual. So why does it still have a red squiggly over is? Okay, that's done. So that's going to be my general outline. Let's see if this is desktop right now. And I could call this property-based testing outline. Okay, so that's going to be my outline. Then over here, I am going to basically get rid of that and get rid of that right here and start from scratch. And this is going to be property, and I think I have to say quiet on success equals true, something like that. And we're going to leave the default for max test to be 100. That's what the default is. So I don't have to be explicit with that yet. And so the test that I'm going to demo is the absolute value of multiplying two numbers is greater than adding two numbers. And maybe I should do that like that. And so then I'll go through how to write a property-based test in which I say that you need to always declare your data generator or your value generator. So then that's when I say we're doing multiplication. So I say let generator equal, and then I say arbitrary dot generate, and within angle brackets I say int. Okay, and then I can say we're going to have our generator, and we're going to have our generator again because we have two operands that we're going to use for addition, and we're going to use this special operator in F sharp, and we are going to say gen.map to, and we're going to take, how is this going to work? I assume the value of that value that's generated from each generator, x, y. How do I do this? I say fun x, y, and then I pretty much create a tuple out of that x, y, like that. And then I can say, oh, come here. Then I can say arbitrary dot from generator, and then I can immediately pipe that into prop dot for all, and then I do a backwards pipe operator, and then I pipe the following into that prop for all function, which is a function that takes the tuple that will now be called AB, and we will say that A plus B is greater than A times B. Okay, and so that's going to be our test. Of course, this is going to be somewhat cryptic to people that are not familiar with with F sharp, let alone the ML family of functional programming. And so I could say, basically, we establish our generator, and then we're going to use this generator to produce two values. Initially, we're going to take these two values that we call x and y, and we're going to map those two values into a tuple that maintains those values. And then we're going to call a function called arbitrary.fromGenerator and pipe that result, the values that came from the generator, into another function called prop.forAll. And so for each value, or for each tuple value that gets generated from these generators that we transform into a tuple, we're going to basically take each value from that tuple, break it down into value A plus B, and say that it's going to be greater than, I did this wrong. This was the absolute value of multiplying two numbers is greater than adding two numbers. Yeah, so this is backwards. I say A times B is greater than A plus B. And so if I go ahead and compile that, oh yeah, so this might be kind of an eyesore. And so we can also rewrite this somewhat so that we can say this instead. And get rid of that. And so when we run this test, I could pretty much within the test do Control RT. I like to think of RT as run test within the editor. So I did Control RT. It's now running the test. And we see that the test failed. And it provides an example of -2 and 1. And so -2 times 1 is going to be -2. Is that greater than -2 plus 1? Well, that would be -1. So is -2 greater than -1? No, -1 is closer to 0, which means that -1 is greater than -2. And so from there, I can say that the math dot absolute value of A times B is greater than A plus B. And that math needs to be capital like this and open system like that. So now if I try to run the test again, it fails and it provides an example of 3 and 0. Okay, so 3 times 0 is 0. 0 is greater than 0 plus, or 0 is greater than 3 plus 0, which is 3. So 0 is greater than 3. Well, that's false. That's the reason why this fell down here. Okay. So this is where I probably will introduce adding a filter in which I would say, let's go back to the original setup that we had, in which I have generator defined up here. Let generator equals that. And then that right there. And that right there. And I guess what I want to do is I want to pipe the generator that we created into a, I think it's arb.filter. Either arb.filter or gen.filter. I think it's gen.filter. Gen.filter. And then we say fun. And then x goes to, and we say x not equal 0. And so what we did was we took our generator, and then we're saying that we want to put a filter on our generator so that we only produce values that are not equal to 0. So if we run that, then we have an issue where it's using 1 and 2. So 1 times 2 is 2, and 1 plus 2 is 3. 2 is not greater than 3, which means that this test or our assumption is false. Okay. Now, if we wanted to, we can maybe update the title. The absolute value for multiplying two numbers is greater than adding two numbers unless any of the numbers is 0 and any of the numbers have 1 in it. We could do that, or we can just rethink. My dog is attacking my foot. Or we could just rethink if this is really the test that we want to write, or acknowledge that our assumption is false. And so that's an example, but if I wanted to keep on going, actually I'm not, because my dog is attacking my foot, and so I can't concentrate anymore. So that's it. What did I get from this? I established a general outline of the talk I'm going to give, and I just wrote some code to basically demonstrate edge cases that are being identified for an assumption that's made. And that's it. I'm Scott Nimrod. I'm available for hire. I am a .NET developer. I also know a little bit of Elm. I prefer to work in F#. I know C# very well, so well that I got bored with it. And so I'm doing this whole functional programming thing. And what I just went over is pretty much making a video of me practicing or preparing for a talk for the South Florida Test Automation Meetup, in which I discuss property-based testing, why it's valuable, and how it can be used. And that's it. So I'm going to practice probably later on tonight. And adios, te veo a ratito. I'm available for hire. I'm Scott Nimrod. Reach out to me. Yo.